We're on the third stage. What is finding your test statistic? Okay. And like we said, once your population variance or the population standard deviation is given, which is given provided in this question here, once it is given, you go straight away to use what? Z statistic. Okay. You understand? And then because it's given to, you are going to use the formula, which is X bar minus mu over the given standard deviation. Okay. It is when it is not given that you use the sample standard deviation. But in this case, it's been given. You said, assuming the population what standard deviation is 8.9. So it's been provided. So we are going to use that, which is sigma is 8.9. And also we're giving X bar, which is the sample standard deviation of 71.8. Okay. So in the formula, we just substitute all these values. S bar is for 71.8. Okay. Minus the claim value here is what? 70 centimeters. So that's 70 centimeters over the standard deviation was given as 8.9. Okay. So 8.9 divided by the square root of N is what? N is what? 1,000 iron rods. So we have 1,000 iron rods. Okay, so you want to calculate this for me. First, compute the denominator and then do that for the total. So do the calculation and let's have the answer. Okay, so once you've done that, I'm sure you notice that you had 6.3965. Okay. And once again, let me caution you, you should have your calculators and your standard tables with you. Okay, good. Now let's proceed. So this is our fourth step, okay, where we select the sample statistic, and in the fifth step, we are going to take our sample and then formulate our decision rule. Okay, cool. So let's go on to the fifth step. How do we get our decision rule? It's quite simple. Now, what we are going to do is we first have to check the sign of the alternate hypothesis, okay? The sign of the mathematical notation, there's the inequality on the alternate hypothesis. And you notice that it is greater than, mu is greater than 70, okay? So if it's greater than, we said, once it's greater than, then our rejection region will be what? On the right hand, if you recall, okay? So once it's greater than, our rejection region is going to be on the right hand. Now, let's draw our normal curve. Okay, so we have our center at 0. And then we are looking at, okay, a probability, okay, on the right hand. Okay, so 1, because it's greater than, is going to be 1 tail, but on the right hand. Okay, good. So which means that we are going to read a Z with the alpha value, alpha value for our critical value. So we will call Z alpha is what we refer to as a critical value. Okay, so we are finding the critical value. And that will be read from the statistical table. So we are going to look for the critical value. Good. Now that means that we are going to read the probability of 0.05, okay, to the right. This is the probability here, 0.05 to the right. Okay, 0.05 to the right. But if you recall, last week in class, I told you that the statistical tables are cumulative probabilities from the left, okay? So you cannot directly find the probability from the right. You rather have to, find the probability of the left and subtract from 1, if you remember, okay? Now, this is a point, and it's a dividing point between acceptance and rejection. So if I can read the left hand, it will still bring me back to the same points. You understand? So instead of reading what 0.05, I'll rather read 1 minus the probability on the right hand, okay? Just like we did in class last week. So that is going to be Z with probability 1 minus what? 0.05. So 1 minus 0.05. 1 minus 0.05 is the same as 0.95. Okay, good. So our Z critical will be 0.95. Okay, good. This is one approach of finding the critical value on the right hand. There is another approach, but we will deal with this first. Okay, so that is Z of 0.95. Now, how do we read Z with probability of 0.95? Okay, so we'll quickly go to our statistical table and then identify this value. Okay. Okay, let me take it again. So in class, we read the probability of Z greater than some value like 1.5, okay? Now you take note that this 1.5 is the Z value, which is read along the column and the row, okay? But this time we are reading Z with a probability of what? 0.05. Now, probabilities are given in the table here. These are the probabilities. So this 0 point something, so these are the probabilities, okay? So you take note of the difference between the Z value and the probability, right? Cool. So we are doing the cumulative probability. And we said because it's on the right hand, we'll rather read Z of 1 minus 0.05, which is 0.95, okay? Good. So we are coming to read Z with a probability of 0.95. Okay, good. So we are going to look for 0.95 here. We have to keep looking from the first value 0.5. So we have to keep going down and down and down and down. As we are going down, you see the values are increasing. So we are at 0.92 here, 0.93, okay, 0.9444. Then we come to 0.945, 0.946. It keeps going, 0.948, 0.949, okay, and 0.950. So you realize that these two values, okay, are very close to the 0.95 we are looking for, right? Good. And more specifically, if you add these two values, try and add it at your end. 0 points, if you add these two values, which will be 0.9, okay, 49497, okay, plus 0.950529. Okay, if you add the two and divide by 2, that is halfway between the two values. You get 0.95 exactly. Try that and then let me know if you got it. So try it at your end. Let me know if you got it by chat. So the numbers we have here, which is 0.9497, has a Z value of what? This is 1.6, okay, 4, right? So the first Z value is, let me write them somewhere here. So the first Z value is what? 1.64, okay? And then for this number here, is 1.65. The Z value is 1.65. Okay, so just like we did this time, we are reading it backward. Good. We've rather been given the probability, and you've been asked to find the Z value. So you rule your horizontal and vertical line, and then read the corresponding Z value. So just like we said, if we add the two probabilities and divide by 2 to get 0.95, which we are looking for, then it means that the actual Z value we are looking for will be the halfway between these two values. Means we have to add them and divide by 2, okay? So the Z we are looking for will be what? 1.64, okay, plus 1.65 divided by 2. Because it's halfway, it's exactly halfway, it's in between. So that Z value will be 1.645, 1.645. Okay, so that is the Z value we are looking for, which is the critical value. Okay, so now that we've gotten this, okay, so you notice that, right, we have our Z critical value, okay, which we just want to read as 1.645, okay, that is a critical value here. That's set with probability of 0.95 was 1.645, okay. Then what next? We have to make a decision. So the decision is about drawing this value. We have to illustrate this value on the graph, okay. The center of the graph is 0. So as we are going, okay, we have positive values. But look at this. If we are to draw this 6 point something on this graph, it's going to lie way on the right side. Okay, 6.3 will be here, right? And from the look of things, it lies in the region of rejection. You can see it. So it's actually lying in the region of rejection here. This whole region is a rejection region. So if your Z is actually bigger than the critical value here, then we have evidence to reject our null hypothesis. Okay, good. So having done that, you can say that since what? Okay, you write this, since, or we can say at a 5%, okay, significance level, or level of significance, okay, what? Our Z value, okay, the Z value, which was 6.3965, okay, was far greater than what? Our critical value, which is what? 1.645. Okay, so you write, hence we have evidence to reject null claim. Okay, good. So if we are rejecting the null claim, right, what are we saying? We said the claim was what? That, let's go back to the null claim and then see what it means. So in our null claim, we said what? we said H, that's the mu, H naught is mu is less than 70, less than or equal to 70 centimeters. Okay, good. And then the alternate claim is mu is greater than 70 centimeters. So if that is the case, we are now saying that because the value lies in the rejection region, we have evidence to reject. Okay, so if we are rejecting, then what are we saying? Then if we are rejecting the null claim, we are saying that in conclusion, so for our inference, okay, we can say that hence, okay, the average length, okay, exceed or are greater than, which is the alternate, that are greater than what? 70 centimeters. Okay, good. So the null said that the average length was less than or equal to 70. So if we have rejected it, then it means that the alternate hypothesis is accepted, which is what? 70 centimeters. Okay, good. So basically, these are the procedures. First, you state your claim. Second, state your alpha level. Third, decide on the test statistic. Fourth, take data, formulate your decision rule. Okay. Then after that, you compare and decide whether to reject or to fail to reject the null claim. Okay. These are the steps involved in hypothesis testing. Now, let's take another example to make it much clearer. So let's move on to the next example. Here we are told that MTN telephone company claims that an average length of phone calls is 8 minutes. So the claim has been reported here clearly, okay, that they are making a claim